Hello everyone, my name is Lina Hussam. Our project is an entrance and parking of a secure building. For the inputs, we use 6 IR sensors. 4 of them are used to indicate the parking slots. The other 2, one of them is used to detect if a car entered the off-limits area, and the other one is used to detect if a car is entering the gate. We use another type of sensor, which is a smoke sensor. It detects if there is smoke in the building. Another input is a password. We use this password to open the gate. If someone enters the correct password, the gate's open. For the outputs, we use a buzzer, which is triggered whenever an illegal action happens in the building. The other output is LED. We used 4 LEDs that displays whether the parking slot is taken or not. For the other outputs, we use 2 BCDs, one to show the number of empty slots, and another one to show the furthest empty slot from the gate. We have an additional output, which is a servo motor. We use it to represent a gate, which opens whenever some conditions are satisfied.
Hi, my name is Naima Mohammed, and I will be explaining the IR sensor part, the hardware. Here we have 4 IR sensors and 4 LEDs. The IR sensors detect whether a car is parked in the slot or not, and the LEDs display if the slot is free. We tried with this car.
Hello everyone, my name is Muhammad Amr, and today I'll be presenting to you some of our components. First of all, our servo motor, which we used as a gate to control the entrance and exit of our building. Second, I'll be talking about the IR sensor that monitors the control of the gate. This IR sensor, we use it not to close the gate if someone is passing through. So the servo motor is controlled by this pulse. It's called PWM, also known as pulse width modulation. So a continuous pulse such as this pulse is used to control the servo motor. This particular servo motor uses a pulse that has a period of 20 milliseconds and a frequency of 50 hertz. The motor decides its position based on the width of the pulse. So for example, if the width of the pulse at this clock cycle is 1 millisecond, the motor decides or determines or takes that as an input or an indication that its position is supposed to be at angle 0. For example, if the input or the width is at 2 milliseconds, the motor switches the position to 180 degrees.
My name is Mariam Tamer, and I'll be talking about the smoke sensor in the off-limits area. The smoke sensor, whenever it detects any smoke inside the building, or alcohol or cigarettes or anything, it is connected to the buzzer and it triggers it. And so is the IR sensor in the off-limits area. It's connected to the buzzer so that, for example, when a car enters the restricted area, the buzzer is triggered. For the smoke detector, whenever it detects smoke, the buzzer is triggered. In the IR, this is the normal entity. We have an input, it's 1 bit, and an output, it's 1 bit. And the architecture, we negated it because it's an active low IR, and here we use the IR as a component to connect all 4 IRs that are used in the parking lot. Finally, we come to the smoke sensor. It has only an input 1 bit and output 1 bit, and it's also active low, so we negated the input smoke to the output smoke, and it will be further mentioned in the top module.
We used an entity counter which takes 4 inputs. These 4 inputs are the outputs of the 4 IR sensors, which represent the parking slots. We used these 4 inputs to calculate the number of empty slots and to be able to recommend the furthest empty parking slot to the user. We then used a BCD component to be able to convert these 2 signals to an output that can be shown on the BCD. We then used a counter component in the entity module, in the module 1 entity, to be able to link between the signals coming out of the IR sensors, the 4 IR sensors, and the C1, C2, which are displayed on the BCD.
Next, we have a module 1 entity. It takes 4 inputs for the 4 IR sensors and uses 4 signals, S1, S2, S3, S4. They are 3 down to 0 vectors. We use the leftmost bit of each vector to display it on the LEDs as output to detect if a car parked in the slot or not.
Okay, so next we have the top module where we assemble all our components. So we have the module 1, which represents all the parking slots. We also have the IR, which we use to make the off-limits IR sensor. We have the component smoke sensor, and we have these 2 signals which we use to trigger the alarm. So as you can see in these port maps, we assign the inputs of the inputs of the system to its outputs, and we also assign these 2 alarms, alarm 1 and alarm 2, to the output of the IR and smoke sensor respectively. So when these alarms are triggered, we activate the buzzer. Next, we have these 2 outputs, out IR gate and open gate, which we use to control the servo motor. So as you can see, if these conditions are satisfied, the open gate command will be transmitted, and we use the Arduino as instructed by our professor as a relay between the FPGA and the servo motor to control it. So if we see the Arduino code, we will see that we receive the open command from the FPGA, and if this command is 1, which means it is activated, we will open the gate, and after a delay of 4 seconds, and after we check that there is no user or car blocking that gate using the IR sensor, we will close the gate.
Here we have the 4 IR sensors and the 4 LEDs. The outputs are connected to the FPGA, and the VCC and the ground are connected to the breadboard.
So next we have our buzzer, which is connected to the FPGA and also connected to the common ground. There we have our smoke sensor, which is connected to the Arduino that we use as a power supply in this part. And here we have our 2 IR sensors and our servo motor, which are connected through these parts using these 2 breadboards, also to common ground and a VCC. So let us now test the entire system. As you can see, in this 7 segment, we have 1, which represents that there is only 1 available slot. So for example, if we have 2 slots, we will have here 2. This other number represents the recommended parking slot, which is the farthest parking slot. So for example, here the farthest one is 2. Now it is 1. The farthest slot is 1. So let us now try to enter the gate as a user. So first, the user will approach the gate and he will enter the password. So here it is 0011 and then submit. The gate will open, you will pass, and the gate will close. So the user can have here different options. He can either park, or maybe he can try to go to a different illegal area and the buzzer will sound immediately. Maybe he can try to smoke in the building or to do alcohol or anything. And then the smoke sensor will be sounded. Then we will test that the gate will not open if any alert is active. So for example, if this alert is active, and the user then tries to enter the correct password and for example enter into the gate, and then we press submit, the gate will not open unless the user is out of the illegal zone. Then the gate will open. If the user is blocking this area, the gate will not close. Say the user tries to enter this time and he blocks the entrance and then he moves along, the gate will not close until he moves along.